So, yesterday, we were looking at denominators in these questions and getting rid of those. We don't like fractions, apparently. So the first step we're going to do for a question like 13 is get rid of all of those fractions. Now, I've given you two methods to deal with that. Either you can multiply everything on both sides by the lowest common multiple, or you can multiply everything on both sides by both or as many denominators as there are. Which way do you want me to do it? The lowest common multiple, okay? So what is the lowest common multiple of 4 and 5? Is 20. So I'm going to multiply every term on both sides by 20. Times 20, times 20, times 20. So when I do that, I'm going to get 20m over 4 equals 20m over 5 plus 20. And now we're going to simplify those fractions. 20 over 4 is 5. So I'm going to get 5m equals 20 over 5 is 4. So I'm going to get 4m plus 20. Now the fractions are gone. This looks just like the stuff that we did a couple days ago. I want to move all of the variables to one side. So the easiest way to do that is to do what? By doing what? Subtract 4m. So those are gone. So 5m minus 4m is 1m. And all that's left on the right-hand side is 20. That is question number 13. Question 12 is very similar. Okay, so that was one of the options for the answers up there, so that's cool. Are there any other questions anyone would like me to do from any other stuff I assigned? I assigned ACEs in parts 1 and 2, but you had answers to these. ACEs all over here. Is there anything excuse me. I'm tired. Anything anyone would like me to do? Going once. Twice. Thrice. 3 times. And then sold. Okay, cool. So all y'all feel like if I gave you a test on this, you could do it right now. If I did. So no, you couldn't do it, but no, you don't have any questions. You understand how I find that a little bit confusing, yes? Well, I would, but my C block used my words against me. They reminded me of something that I told them at the beginning. So on this booklet, this is the wrong front cover, and the correct front cover, which I showed you guys, had no quizzes listed. So I changed the order and I removed some stuff. Had no quizzes listed. And I told my C block class that because I took the quizzes off the schedule, I'd let you know in advance when they were coming. And I didn't today. And I tried to give them the quiz, and they're like, but you said. And then I was like, you're right, I did say. And I would like to remain a teacher of my word. And so because I did say, I said, fine, it'll be tomorrow, but I'm adding 50% more questions. So there was an 8-question quiz. It is now a 12-question quiz, and I added today's work on there. So that wasn't on there. So I said, this is the trade-off. And they said, oh, yeah, okay. So because that's what C block chose, that's what you guys are experiencing as well. Why? Well, because usually C block suffers by your guys' choices. So today it's the other way around. Well, the quizzes has moved, which is a good, but the quiz is now 50% longer than it was, which is a negative. So do what you want with that information. Here we go. Well, unless I say you have 20 minutes to get this done. So this is the other half of the lesson that I could have given you yesterday, but I gave you guys your test back. We spent some time going over it. I didn't want to cram all of this lesson into one block, so we're going to do the rest of it today. And I've got a boatload of practice for you guys to play with afterwards. So I'm going to do 2 examples of this kind of stuff. I'm going to give you some methodology, some techniques, similar to the stuff that we did yesterday, but Scarlett, there's one added little twist. So let's look at binomial numerators. Scarlett, did you get Noel's calculator? No. Come on! You say, I'm not going to give you your iPad back until you give me your stupid calculator. Okay, so when you've got binomials in a numerator. We've seen this before in the polynomial chapter. We're going to take a look at this here. These are going to behave slightly different than we did in the polynomial unit. Because in the polynomial unit, I would give you guys things like this, and I'd say, okay, well, you've got a binomial over a monomial, divide that thing. In this chapter, we don't want to do that, because what we're trying to do is isolate for the variables that are in there. So we're going to combine some of the techniques we looked at yesterday with the ideas that we looked at in the polynomials unit last chapter. So, ignoring the first step for a second, if you look at steps 2 and 3 here, they are going to look very similar to the stuff that we did yesterday. You finished your test? Nice, throw it in the bin. So, one of the techniques I showed you guys yesterday was still to find the LCM of any denominators that are present, and then to multiply every term by that LCM, simplify the fraction. That piece has not changed. Yesterday, I also added an OR in here. Instead of multiplying by an LCM, the other technique that I showed you yesterday is also still true. Or instead of doing this, you can multiply by both, or as many as there are, denominators. Simplify. And then step 3 comes into play. If needed, distribute. Well, why would we need to distribute? Let's look at how these things behave. So I want to show you both techniques, using the LCM and using not the LCM. I've got 2 examples that I'm going to do, 2 questions I want you to do as practice, and then once you've shown me you can do these 2, I'll free you to work on the homework. So when we've got this written as, so I've got a binomial numerator, 3x minus 1 over 3, and over here I've got a 2x plus 7 over 5. We need to treat these binomials as a single mathematical object. It's this whole thing, 3x minus 1, divided by 3. And it's this whole thing, 2x plus 7, divided by 5. So because we need to treat it that way, the first step that I listed here that I told you to ignore for a sec, we're going to come back to now. Put brackets around that numerator. And the reason we put brackets around that numerator is because what we're going to end up doing here is we're going to multiply by some stuff. And when you multiply a binomial by some stuff, there are techniques that we need to do, namely distribution, and we need to distribute properly to make sure that every term gets multiplied appropriately. To do that, we add the brackets. So add the brackets around the numerator, and I'll show you this one first, the or multiply by both denominators first. So I've got multiple denominators here. I've got a 3 and I've got a 5. So what I'm going to do is I'm going to multiply both chunks on both sides by those denominators. So now I've got my numerator inside the set of brackets. I'm going to multiply by 3, and I'm going to multiply by 5. I'm going to multiply by 3, I'm going to multiply by 5. So just like I'm dividing this whole thing by 3, I'm also multiplying this whole thing by 3 and 5. Using this technique, and you might be getting the hint that this is my preferred technique, and I think that the more of you that get comfortable with this, the better off you will be long term, but you don't have to. With this particular technique, it's easy to see what's going on here. I'm multiplying by 3 and I'm dividing by 3. So because I'm multiplying and dividing by the same thing on this side, that's what's going to cancel. These 3's are going to cancel, and I'm going to leave the multiplication by 5 outside. On the right-hand side, what's going to cancel? The 5's. I'm dividing by 5 and I'm multiplying by 5. So my denominators have been canceled by multiplying by, at least by them on both sides. And so what I've got left here is this 5 multiplying onto this entire binomial, and this 3 multiplying onto this entire binomial. And so what I need to do is, just like we did it in our polynomials chapter, when I multiply a monomial onto a binomial, I need to multiply every term. I need to distribute it fully. onto the entire binomial. So what I'm going to get here is 5 times 3x, which is, I multiply my coefficients, and the x comes along for the ride. Austin Joe says that's 15x. This is where I made a mistake in the first class. 5 times negative 1 is negative 5. I did a fantastic job in the first class of demonstrating forgetting to distribute onto all of the terms. And then a bunch of hands went up. Dweedop, you forgot this piece. Yeah, you need to make sure that each piece here gets multiplied by what's outside. The left-hand side is done. The right-hand side is, I've got a 2x plus 7 multiplied by this piece here. So this guy needs to get distributed onto both pieces here. 3 times 2x is 6x, and 3 times positive 7 is positive 21. And now this looks just like something we did 2 days ago. I've got variables on both sides. I've got numbers, constant terms on both sides. So I want to get my variables all on the same side. What's the best way to do that? Yeah, because I've got a 15x here and a positive 6x here. If I subtract both sides by this is going to stay positive. So I'm going to subtract 6 on both sides. It's positive here. Subtracting by 6x cancels that out. 15x minus 6x is 9x. Nothing's happened to that minus 5. That equals 21. Now I still want to get this x by itself. I need to get rid of any terms that don't have an x in them. So I'm going to get rid of this negative 5. How do I get rid of the minus 5 portion of this question? I'm going to add 5 on both sides. We get 9x equals 21 plus 5 is 26. Now I've got 9x. I don't want 9x. I just want x. So what do I have to do? Divide by 9. Divide by 9. 9x divided by 9 is just going to give you x. And 26 over 9 does not simplify. So this is a totally acceptable final answer. You do not need to convert that thing to a decimal. Some students in the C block class this morning insisted on converting that thing to a decimal, and then they screwed it up. If you're going to convert that thing to a decimal, the easiest thing, if you don't have a calculator, is to convert this thing to an improper fraction. Sorry, it is improper. Convert it to a mixed fraction. 9 goes into 26 twice. 9 times 2 is 18. 9 times 3 is 27. So twice with 8 left over. So this is going to be 2.8 repeating. But I would encourage you guys, especially those of you who are like interested in pre-dib 10, interested in going into regular 10 because you want to do pre-calc 12 and calculus, the more comfortable you can get leaving things as fractions, the better off you will be long term. But ultimately right now, my biggest concern is this portion. So this particular technique, we multiplied both sides by both denominators. Over here, if there are no questions about what I've done, are there any questions about what I've done? Okay. If there are no questions about what I've done here, let's slide over here and I'm going to do the other method. So the other method is, let's find an LCM. What is the LCM of 2 and 4? LCM stands for lowest common multiple. It is the smallest number that 2 and 4 both multiply up to, Josh. It is, in fact, 4. Does anyone want a refresh on how to find the LCM? Nobody wants a refresh on the LCM? We can all find an LCM relatively easily. Okay, cool. If there are no concerns about LCMs, we found it. It's 4. Let's use it. So the instructions with the LCM to say, multiply every term with the LCM. Okay, well, I've got those binomials in the numerator. So because of the way this thing is currently written, this big block is one term. So I'm going to multiply both sides by that LCM. I'm going to extend the line. I'm going to multiply this guy by 4. I'm going to extend the line. I'm going to multiply this guy by 4. Before we do any distribution, I'm going to make some simplifications here. So I'm multiplying both sides by 4. This is the piece I'm going to deal with first. What's 4 divided by 2? 2. So because 4 divided by 2 is 2, I'm going to simplify that piece there, and I still have the 2x minus 3 in brackets there. On the right-hand side, I've got multiplication by 4 and division by 4. So what's going to happen with these two 4s? Those guys are going to cancel because 4 divided by 4 is 1. So what I'm going to be left with here is negative x minus 1 times 1. And now we distribute. So I'm going to multiply this 2 in here onto both those terms. 2 times 2x is 4x. 2 times negative 3 is negative 6. That's going to equal, well, multiplying by 1, positive 1 doesn't change anything. So I can drop those brackets, and I'm just going to get negative x minus 1 here. Now I want to get x by itself. So I want all the variables on one side, I want all the numbers on the other side. What is my first step to making that happen at this stage? Jacob, is that what you were going to say because you put your hand up? That's not what you were going to say? Ooh, fantastic. I love that both of you just said what you said. We're going to do the exact same thing because that's exactly the same thing that happened in my other class this morning. We're going to do both those steps at the same time because we can. I'm going to show you guys now how to shorten some of the work you're going to do here. Scarlett, you said, let's move all the letters over. I've got 4x's here, I've got a negative x here. If I add x to both sides, you can see that that's going to cancel this guy out. Jacob, in the same breath, you said, well, because I've got a negative 6 here, let's add 6 to both sides to get the letters alone over here. You can do both of those steps at the exact same time. And there's no reason why you can't. As long as you show me your work, there's no reason why you can't write that up. And you can see here what's going to happen. The negative x and the positive x on that right-hand side are going to cancel out. On the left-hand side, that negative 6 and positive 6 are going to cancel out. They're going to add to 0. So I've dealt with all of that middle term in one shot. I've got 4x plus x, which is, and I've got negative 1 plus 6, which is 5. Thank you, Scarlett and Jacob. Appreciate that. And now I've got one step left. I have 5 times x when there is no symbol in here. Remember, it's multiplication. So to undo that multiplication, I'm going to, Zara, was that you? We're going to divide both sides by 5. 5x divided by 5, the 5's cancel, and we're left with x. On the right-hand side, 5 over 5 is 1. Questions about anything I've just done? Justice. Oh no, that wasn't a hand. Okay, then let's make a check. Let's see. Can you guys see that on the screen? Because I definitely can't. We're good? Okay. Let's check it. I want to take this value and I want to plug it back into my original equation, both sides wherever there's an x. So let's write it out. I've got 2x minus 3 over 2. That's going to equal negative x minus 1 over 4. And the way that I told you guys to do the check is that wherever there's a variable, throw out a set of brackets, and then take the value that you think belongs to that variable and shove it in those brackets. So we're going to get 2 bracket bracket minus 3 over 2 equals negative bracket bracket minus 1 over 4. We think that x should equal 1. So this is what this check is going to look like here. Now, if you remember back to BEDMAS, when I gave you questions like this, We need to finish the numerator before we do anything else. So let's take a look at this. The first step into the numerator is to go 2 times 1, which is 2. 2 minus 3 is? -1. Okay, so I'm going to get -1 over 2 on the left-hand side there. On the right-hand side, I've got -1 minus 1. -1 minus 1 is? -2 over 4. Are those equal? Is -1/2 equal to -2 over 4? Austin Joad is correct. He says yes. And that's because you can reduce this fraction on the right. You divide top and bottom by 2. You get -1 over 2. And we're done. Nice and easy. Comments, questions, concerns about what I've done there? So because this check is true, this value is correct. So the only thing that gets added to today's style of question is this idea of how to deal with these binomials. Throw brackets around those binomials or trinomials or polynomials or whatever shows up there. You have to multiply everything, every term. So down here you've got some 3-termed things. You have to multiply this guy, and the 7. This guy, and this guy. Whether you choose to multiply by each denominator or multiply by the LCM, you will have some simplifying to do. You will almost certainly have some distribution to do. And then you isolate for your variable, whatever it happens to be. Before I tell you what I'm going to leave you for practice, I would like you to take a look at these 2 questions. I've got answers for both. When you think you've got the answer, I want you to let me know. I'll come around and I'll help. Try these 2. I don't care which method you choose to use, whichever one you are most comfortable with. When you feel like you've solved it, let me know. Yes, Sean. Is this a type of... Yes, it is. You're correct. They are in. Multiply this guy, this guy. Multiply each chunk on each side by everything you're choosing to multiply by. That is the single most common mistake that I see. When you've got this, 6n plus 3, they're on the same side of the equal sign. So you don't need to do any opposite operations. You can combine. 6x plus 3 is 9n. Everything you've done is correct, right up to that point. Now just keep the 6 and just the x. So you're almost there. Yeah, well. You have to multiply everything on both sides, yes. Including that 7. Use a click out. Like that. Don't forget to multiply this guy as well. Everything on both sides. Oh, right.
for reminding me.
No worries. Everything on both sides needs to be multiplied. So you multiply. Oh, hold on. No, you're good. You're good. You did it a different way yet. The way that I'm not showing these guys. Just make it more confusing. But you're welcome to do it that way. Just don't screw it up. Multiply 6. Well, 3 and 6. So you've got 6 and that should be 6 and minus 6. Row level minus sign. Okay, good. 6 is the calculator. So you can show more work. So if you cross this guy out, you multiply this guy by 3 and 6, right? Well, you also have to multiply the 7 by 3 and 6. You make sure you multiply this piece and that piece. So here, when you multiply this, you cancel out the 6, because you just multiply there and there. Then you have full sign here. You can multiply this guy by 3 and 6. Divide. Because this will be multiplied on top. Divided by 2. That's why you have to multiply by the L. So if you're going to do it this way, you should multiply by the LCM. You don't have to do it this way. If you like this way better, do it that way. No, you're not. That's correct. Keep going. You're like terms. If there are like terms, that's the next step. Correct. Yeah, so 6 and plus 3. If you can figure that out, you will have correctly solved that question. Nothing, because you didn't figure it out. The left one's wrong. Yep. I made a mistake on the first line. First line is correct. One mistake. That's correct. If you bring a 6 this way, don't forget that there's a plus 10 here equals 0. So what you're doing, you added 6 here, right? So negative 6x plus 6x, which is going to be this. You have to actually write the 0 and the equal sign. You have to put this. If that's the only thing that's left, you have to put it. So the way that Jeremy shows, if you move things the other way, Jeremy wants to move everything to the left. You move everything to the right. Yeah. The left one is the right one now. No, you don't calculate it on the you multiply everything here by 2. You multiply this by 2. You didn't multiply right by 2. Show how more work to solve that problem. Fair enough. Easy. Okay. Both correct. Both correct. Both correct. That's correct. That one's not. Let's take a look. Careful. What is negative 1? Negative 6 plus 1. Negative 6 plus 1. That's your only mistake. Okay, so I'm seeing lots of you guys making very real progress to the correct final answers. I will tell you what the answers are. Lots of you have reached them. That's great. What you guys are looking for is that the left question. Gentlemen, Faison, give me 1 sec. M is equal to 14. And is equal to 14. Whatever the variable is equal to 14. And on the right-hand side, x is equal to negative 2. Lots of you have reached that. That's great. If you haven't, I'll come assist you. Give me a second. Because of the number of you that have successfully pulled this off, and some of you are sitting beside some of your friends who haven't, by all means, feel free to help them, or call me over if you can't. But I do want to give you guys the homework now for the day, because lots of you guys are ready for it. If you flip ahead, Jacob Scarlett, give me 1 second, and then I'll give you guys time to talk. The stuff from yesterday was part 1, part 2, aces. Today we're going to start up here with part 3. Here's what I want you guys to do. Part 3, I want you guys to do aces. Part 4 down here, I want you to do B, D, and F. Part 5, if you flip the page, so aces up top in part 3, B, D, F in part 4, flip the page. Part 5, I want you to do aces again. There's answers down there at the bottom. And then if you flip the page one more time, this double cross page is for homework as well. The page that comes after this one is optional extra practice, but there's answers to it as well. There is a ton of practice for this kind of stuff. I will also tell you that the 4 questions I added to the quiz come from the pages I just assigned, not necessarily the letters I assigned, but the pages I just assigned include the 4 questions I added to your quiz. So if you do all of them, you will have had a chance to do a third of tomorrow's quiz. So that's what I want you guys to take a look at: aces, BDFs, aces, and the double cross page. And that is, you've got just over half an hour, lots of time to figure this stuff out. The whiteboards are available to you. The biggest issues I'm seeing before you guys leave and work, I want to bring your attention to a few things. The biggest thing I'm seeing comes when you guys are not showing all the work you could. When you're multiplying this piece and this piece, almost half of you forgot to multiply the 7 as well. If you're really, really deliberate, and it was the same thing in my C block class this morning. If you're really, you got to be really, really deliberate. If you're multiplying by everything, multiply by 3, multiply by 6, multiply by 3, multiply by 6, and write it out on the last one as well. Each piece, both sides. That was the biggest issue I saw. Over here, it was the same kind of thing. Following that, the only issues that I'm noticing are things like telling me that 3 times 6 is 9, and then multiplying 7 and 9 together to get, what is that, 84? No, 50, 63? The algebra or the simple arithmetic, those mistakes I can't help you with. You've got your calculators, you've got your multiplication tables. But at the end of the day, it's these bigger issues that we want to make sure we get. So if you need a hand, let me know. Again, 14, -2, and I've got the homework assigned there. The videos will be up if you want to take a look at those, and the rest of class is for you to practice and for me to help. So get to it. Let me know where I can assist you, or feel free to assist each other. Giver.